I will be showing you one Java program. So I'm opening the blue J. So you can see my screen. I'm opening the blue J. I'm just maximizing this particular bar from here, and I'm opening the project which has already been done. So I'm opening this project. Fine. So the recent project which I have done. So we can go to open project, and I can open the school project. Yes. And this is the particular program on orders number. So if I increase the fonts, you'll be very much able to see. So how I increase the fonts, I go to the option, and to the preference I can make that to 22. Yes, I'm making it to 22. So 22 I make, and okay, I make from here, and I see that over here in number theory, and orderless number is a positive integer that has an odd number of ones in its binary expansion. So if you're going to change into binary, you'll find that number of ones, if it is has an odd number of ones, then it is called the orderless number. And examples are 1, 2, 4, 7, 8, 1, 1, 11, and 13. We know that 1, we can give 1, so we can even give 7. Okay, so now we come to and give some of the examples are there, and dot 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 is given, and non-negative number integers that are not orderless are called even numbers. So it's termed as even or non-orderless, you can tell. And write a program in Java to implementing the same concept as specified in the question. So how do we write the program? A program to implement the working of the odious number. Okay, ODIOUS number. So the number of ones should be the odd number, which is already told. And now we see that odious number. So if the class opens from here, the class opens from here, and we find that these variables we declare globally as the global variables, and we make the default constructor over here, where the constructor will automatically initialize the variables to 0. So now we come to the binary. We find that there we use the function calls itself. We have used the binary equivalent of a number of a screen. So recursive method to calculate the binary equivalent of a number in a string format. So this is n2 is the number that is getting in. Yes, n2 is the number that is been getting in, because you find that n2 is coming over here, and this n2 greater than 0. So you find over here that we enter the number as n over here, and this n enters the binary. Yes, binary. And when it comes to binary, it is coming to as n2 over here, and over here the variable is being extracting the remainder to find out the creating the string and invoking the function itself. So over here it is rather calculating the binary equivalent of the number in string format. The string format, because you find this is in the particular string format. Yes, is a string format b2 being 2, where you will find that over here we are accepting the number, we are taking the number there, the binary we are converting the number, and the binary is coming over here. The binary equivalent is shown over here from the calculation of the recursive method. Okay, and we come to this particular portion, and from here we convert to string, and this is being converted, and so we find the length of that number, calculating the length of the binary number. So trying to find out now the binary length of the number, so that we can extract the particular digit as that is 1, and find out how many ones are present in it. So if his number of ones are odd, we have already told, then in that case it is told as odious number, right? So here we take care of the particular ones and the binary equivalent, and over here the number of ones has been counted, the counter has been taken. So if the number of ones percent also, here we are finding the odd, then it is orderless, or else not. So we are printing orderless, also not. So we have already told one example of orderless number. is 7, so we compile, so no syntax error is there. Close it and give the input as 7. We can do that. The input we can make it as 7. So let us void main run and input as 7. So it is an orders number. So let's see. The equivalent is 1 1 1 3 ones are there. So once the present in the number 3, so it's an orders number. Yes, that's it. So I learned it and I'll show it to you. Thank you. So you now understand how to do the particular program nicely. Yes, that's it. So more I will be giving you in the next video. Thank you.